Here we are, folks. Welcome to the kickoff of Blazing into Summer. I am your host, Ed Charbonneau, and I've got some wonderful guests coming up all week, and I have one to just introduce here shortly. Let's take a quick look at what we're doing this week on Code It Live before we get started. This is the Blazing into Summer 2.0. This is the second time we've done it. We had this event last year. Fantastic bunch of guests came on, and we had a wonderful week of building apps live on stream. So today we're kicking things off with the one and only Daniel Roth. He is Principal Program Manager at Microsoft, and I will introduce him shortly. He's going to talk about all things that are new in Blazor in .NET 6. So the previews are out, the bits are hot, and he's going to share what he's been working on with his team. Tomorrow, on Tuesday, we have SignalR real-time apps and Blazor translation. So we're going to have Layla Porter. You might know her as Layla Codes It from the Layla Codes It channel on Twitch. She's going to join me at 10 o'clock Eastern Time tomorrow afternoon, and it is her birthday, so come by and wish her a happy birthday. Wednesday, we have the developer that created the unit test framework for Blazor called BUnit. He's going to come on. He just released the 1.0 release of BUnit just a short time ago, and he's going to show you the best practices to use when unit testing your Blazor applications. On Thursday, we're going to move to a new time slot at 11 o'clock Eastern Time. We have Curious Drive with us on the show on Thursday. He has a fantastic collection of Blazor courses on YouTube that are free, and you can check those out. And he's going to come on and talk about a demo app that he created for his YouTube channel. And then finally on Thursday afternoon, I'm going to jump over to the Microsoft channel and do a presentation with Cecil Phillip on .NET Live. So make sure you stick around Thursday afternoon at 4:40 Eastern Time for that. And then on Friday, to wrap things up, we have the wonderful Fierce Kittens from Twitch. And she's going to come on and show us some UX workflows with some drop downs and things like that for her GIF bot application that she's been building. So we've got folks here that are building all sorts of cool stuff. They're going to come on all week long and talk about what they're passionate about with Blazor. And there's no better way to kick this week off than to bring on the program manager in charge of all of this, Daniel Roth. So let me bring Daniel Roth on.
Hey, Ed, how's it going?
How are you doing, Daniel?
Oh, man, I'm doing great. It's almost the end of the school year. Summer's almost here, at least in the northern hemisphere. My kids just got vaccinated, so we're almost ready to get out in the sun and have a lot of fun. And yeah, excited to be here to talk about Blazor.
Awesome. We are excited to have you here. And you've got some great stuff for us today, and I'm going to stay here and monitor chat and see what kind of questions people have. And we've got brand new preview bits to play with, so I'm sure there's some things that you would love to share with us today. So I'm going to go ahead and share your screen, Daniel.
All right.
And the floor is yours, my friend. Take it away.
Things are going to be smoking hot off the press for this one. Lots of preview bits, lots of new stuff. Yeah, thanks everyone for being with us today and watching. My name's Daniel Roth. I'm a program manager on the ASP.NET team at Microsoft. It's great to be here with all of you, and I'm really excited to get to show you what's new in Blazor in .NET 6. Now, for those of you who still haven't heard, and you're here learning about Blazor for the first time, Blazor is a web UI framework for building client-side web UI using .NET and C# instead of JavaScript. Now, .NET has always had great support for building server-rendered web apps, but if you wanted to do anything that ran client-side in the browser on the user's device, well, that meant writing some JavaScript. Blazor enables you to build full-stack web apps with just .NET. You can use your existing .NET skills, your tools, your code on any part of your web app. Blazor is open source, it's cross-platform, and it runs in any modern web browser using only open web standards, HTML, CSS, and C#. Blazor is part of the ASP.NET Core web UI framework, or web framework, your complete modern web framework for .NET. The addition of Blazor to ASP.NET Core expands the reach of your .NET web apps to the client. There's no need to rewrite your existing ASP.NET Core apps to use Blazor. You can add Blazor functionality to your existing pages and views without having to change anything. Now, how does this all work? Well, Blazor works in one of two different ways. The first way we call Blazor Server. In a Blazor Server app, your web UI components run on the server using .NET Core or .NET 5. And all of the UI interactions and updates are handled using a real-time WebSocket connection with the browser. Blazor server apps are fast to start up and simple to implement because all your code stays on the server. Support for Blazor server shipped with .NET Core 3.1 LTS and also with .NET 5 this past November. The second way Blazor apps work, we call Blazor WebAssembly. Blazor WebAssembly enables running .NET code directly in the browser using a WebAssembly-based .NET runtime that gets deployed with your app. When paired with .NET on the server, Blazor WebAssembly enables full-stack web development with .NET. Blazor WebAssembly apps are true client-side apps, so they can be deployed as simple static sites, and they can even run fully offline, like in a progressive web app. Blazor WebAssembly is available with .NET 5 as well. Now, regardless of which way you choose to host your Blazor components, the way you write your Blazor components is exactly the same. The same Blazor components can be used with either hosting model unchanged. And this means you can take advantage of a really rich ecosystem of open source Blazor component libraries in your Blazor apps, regardless of how they're being hosted. You can find many Blazor open source projects from the Awesome Blazor repo at aka.ms/awesomeblazor. There are also many great commercial Blazor component offerings available from Telerik and many others that include everything you need to build apps fast and have them look stunning. Now, .NET 5 shipped last November, and .NET 5 added a whole bunch of new functionality for ASP.NET Core and Blazor developers. It, of course, included support for both Blazor Server and Blazor WebAssembly. We did a lot of work to improve Blazor WebAssembly performance. In .NET 5, component rendering and JSON serialization, I think, was like 2 to 3 times faster than previous releases. We have built-in support now for component virtualization, so you can render those giant grids and big lists of data really, really fast and efficiently. We added support for lazy loading, so you can chunk up your Blazor WebAssembly app and load it in pieces instead of one big chunk. We added support for CSS isolation, so you can have component-specific styles. We added support for JavaScript isolation and object references, so that if you want to reuse existing JavaScript code, you can do so really, really easily. We also did a bunch of work so you can write more C# and have to rely on JavaScript interop a lot less for common scenarios, like, for example, setting the UI focus. Now, .NET adoption continues to accelerate, and .NET 5 is actually the fastest adopted version of .NET ever. While .NET Core 3.1 kind of set the record, the previous record, with 3 million downloads in the first 6 months, .NET 5 smashed that record with over 3.6 million downloads in the same initial time period. Who's using Blazor today? I'll highlight a few customers. One example is The Postage. They offer services for end-of-life planning. The Postage helps you arrange your important documents and accounts so that they can be managed by your loved ones, by your survivors. By using Blazor for their web app and Xamarin for their mobile app, The Postage was able to have their very small and agile engineering team work across the stack, saving significant cost. GE Aviation is an industry leader in airline systems. Their Flight Pulse app puts sensor data and analytics into the hands of thousands of pilots to help them improve safety and efficiency. The backend configuration of what data the pilots actually see, that's all done using Blazor. We also use Blazor internally at Microsoft. Microsoft Endpoint Manager is a product for managing devices in enterprises. They built their Community Hub feature using Blazor. The Community Hub allows IT admins to share scripts and reports and other management objects with each other. It's hosted on Azure and then embedded in their existing WPF client using an embedded browser control. And lastly, Dynamics 365 is another example. Dynamics 365's connected store offering is a new offering to help optimize in-store optimizations with real-time observational data. The in-store setup and configuration for Dynamics Connected Store is all done using a Blazor web app as well. So if you haven't used Blazor before, getting started is really easy. You just want to go to blazor.net and download the latest .NET SDK. You can then develop your first Blazor app on your preferred platform using Visual Studio, Visual Studio for Mac, or Visual Studio Code. Now, the next wave of improvements to .NET and Blazor is coming in .NET 6 later this year. The work plan for .NET 6 is broken down into various themes that are published publicly on the Themes of .NET website, which of course is a Blazor site. The main themes for .NET 6 include making it easier for new developers to get started with .NET, expanding support for building cross-platform native client apps, ensuring that .NET has everything you need to run natively in the cloud, ensuring that enterprises relying on long-term support or LTS releases have a smooth upgrade path, strengthening the .NET ecosystem, making development with .NET faster and more productive, and lastly, making sure that we continue to deliver on the promises of the .NET platform. That's sort of our catch-all for finishing stuff that we've already started. So if you want to explore these themes, let me see. I think I've got not this. Yeah, the Themes of .NET sites right here. So you just go to Themes of .NET. You can see all the themes, and you can drill down into all of the epics and user stories and check out progress, see what's already shipped in the latest preview releases. For convenience, we've actually consolidated all of the ASP.NET Core and Blazor related items in this ASP.NET Core roadmap for .NET 6 issue. So go and check out that. Yeah, hopefully it's the most transparent planning for a .NET release that we've ever done.
I just shared that link for you in chat there, Daniel.
Perfect. Great. Yeah, definitely go check that out. It's all on GitHub, so you can follow the PRs and the design notes as they come live. Now, there's a lot of new stuff coming to Blazor in .NET 6. Honestly, way more than we have time to go over even today. But to give you a taste of what's coming, we're going to look at 6 great new Blazor features. We're going to look at .NET Hot Reload. We're going to look at state persistence during pre-rendering, error boundaries, WebAssembly ahead of time or AOT compilation, smaller download size, and Blazor hybrid apps. Hopefully we'll have time at some future point to talk about all the other great stuff, but you can keep up with our release announcements to learn about all the other great features coming to Blazor. Now, the easiest way to show these features is to just jump to the code. So let's go ahead and do that. Demo time. All right, so let's check out these features. We're going to start out with .NET Hot Reload. .NET Hot Reload is the ability to very quickly make code updates to your running app during development without having to restart the app. All right, so very fast iterative development. And this is not specific actually to Blazor. .NET Hot Reload is a feature coming to all of .NET 6 for all the different app models, ASP.NET Core, MVC, Razor Pages, mobile and desktop development, and of course, Blazor as well. Now, to show .NET Hot Reload in action, we're going to do some work on this simple picture editing application called Picture Fixer. I've left myself a little to do here in the code to actually start listing a list of pictures that we can then edit using the application. All right. Now, this is a Blazor WebAssembly app. And for this demo, I've already actually started the app with .NET Hot Reload enabled. I did that actually from the command line. So I've got this, command prompt in the background where I've run .NET Watch. .NET Watch is enabled with .NET Hot Reload. But everything that I'm going to do here in VS will soon be fully integrated into Visual Studio as well in an upcoming Visual Studio release, an upcoming Visual Studio update. Okay, so to do this, let's go find the code for our little to-do. And let's just change it to something else, like, hi there, everyone. And I'm going to hit save. And then almost immediately, it updates in the app. It's so fast. Like, let me do it again. .NET Hot Reload in Blazor rocks. Okay, and then I'm going to put my mouse over the save button. Watch this. 3, 2, 1, save. And like basically as soon as you click the button, like the app has been updated. It's great. So .NET Hot Reload, what it's doing is it's calculating what's changed in the .NET IL and then pushing that into the running applications, like patching the running app. So it's very fast to do. Also, it preserves the app state. The app doesn't restart. So any state that you have, like a complicated form or a deep nested tree view, it's preserved so you can continue to iterate and make progress on that part of the app that you're already working on. All right. Now, this app is fetching a list of image data from the server. That's this HTTP request down here at the bottom. And then saving it in this images variable. And I want to print a list of all those images. So let's do a little for each loop right here. And let's make that formatted nicely.
What I hope is a quick question for you, Dan. The hot reload, what scenario does that work under right now? And then what is the plan for release? Is it like all like server, WebAssembly, etc.? What do we have now? What's coming up?
Oh yeah, so it works with Blazor Server, Blazor WebAssembly, MVC, Razor Pages. All those things are available today. You can just use .NET Watch to try that out. And like I said, in the future, you'll be able to do that with VS. There is some really initial support, I believe, for MAUI and for desktop scenarios. It's still a bit of work in progress, but the best place to get the full update on all the current workloads is there's a really nice blog post on the .NET blog. Let me see if I can find that really quick. So dev blogs, and we don't want the HTML blog, we want the .NET one. Let me pop this out so everyone can see. So I'm just going to devblogs, microsoft.com.net. This is the .NET blog. And then somewhere down here, if I just search for hot reload, they blog so often, things go down the list pretty quick. So this blog post, introducing .NET Hot Reload experience for editing code at runtime. Dimitri walks through all the latest updates for .NET Hot Reload. So that's where I would go and check out right there.
Excellent.
But all the
I'll
workloads.
find that and share that with chat.
Perfect. All right, all the workloads will have .NET Hot Reload by the time we're done with the .NET 6 release in November. Okay, so we want to loop over our images. So I'm adding this for each loop, and then I have a little image list item component that I'm going to use to render each image. And that's this component right here. And right now it's just rendering a div. So pretty simple. And again, I'm going to save, hot reload that into the app, and boom, we've got our list of at least the image names so far. So let's start messing with the markup of our image list item component. Let's add some styling and add a class. Let's see, what do we want to do here? We want to do a background. Let's give us a white background. Let's save. Yeah, almost immediately updates. Let's add some margin, save. Let's add some padding. These are all Tailwind CSS styles, by the way. You don't have to use Tailwind. You can use Bootstrap. You can use whatever CSS you'd like. The dev that wrote this app just happens to like Tailwind, so that's what we're using. Add some padding. What do we want to do? Let's add some drop shadow so those things pop a little bit. Let's add a little bit more so it's a little bit bigger. And as you can see, you get this like iterative dev workflow. You just make changes, you see the updates in the UI almost immediately. So it works great for markup. I don't want to bore you like writing a whole bunch of markup live, so I'm going to copy in a snippet with the completed markup that I want right there. And again, I'm just going to save to hot reload that whole thing into the app. And now we've got some beautiful little list items here showing the image, showing the text, and then how long ago they've been updated. So hot reload for Blazor component markup, working great. But it's not just about markup. We can also .NET Hot Reload code changes, like just C# code. You may have noticed that this new markup is using this humanize last modified method, C# method, to figure out what string to render at the bottom of each of these list items. Let me expand that code. Here's the C# code for determining that string. And we can just mess with this. Let's change this from updated to last changed. This is a C# string. We'll save that. And it immediately just updates. Maybe we want this to be edited. Yeah, looks great. So we can do C# code too. And we can also do CSS. We can do CSS hot reload. Let's go mess around with like the theme for this app. Where is that? That would be in the main layout. Yeah, here's our component-specific style for the layout for this application. We've got this theme color variable set up. It's got this sort of green theme right now. Let's change that maybe to something more red. We save. And the CSS changes also get pushed into the running app without having to restart. So that's .NET Hot Reload. You can do markup, C#, CSS, .NET Hot Reload and .NET 6 makes developing ASP.NET Core and Blazor apps, really any type of .NET app, way faster and much more productive than ever before.
And these CSS variables you're using here are just native CSS features, which is something that I actually love about Blazor, is that you could just use any HTML or CSS standard tech and it works.
That's right. Open web standards all the way down. There's nothing proprietary here. I'm actually going to switch this back to green because I like the green better. There we go. Okay. All right. So that's hot reload. Next, let's take a look at error boundaries in Blazor, the new support for error boundaries. So error boundaries are components that can capture unhandled exceptions from the component tree and allow us to react to them. And this is really nice because this really cleans up how you do error handling in Blazor. Blazor today can get a little messy sometimes with all the try catches and trying to consolidate how those exceptions get handled. Error boundaries make that really simple and clean. All right, now to show how
go on to error boundaries. Sorry to interrupt you there, Daniel.
Yeah.
We had a question about hot reload that I think is pretty important here. Somebody's asking if new files are added to the project or a project reference, how is that handled?
Yeah, so in some cases, like as much as possible, we will use hot reload to update code into the app. I can't remember what the current state of adding new files is. I think new files was still considered a root edit last I checked. That may have changed because the set of things that we support with hot reload is expanding in .NET 6. If you're familiar with edit and continue support in Visual Studio, that gives you at least an initial understanding of the types of C# edits that are supported with .NET Hot Reload, at least initially. But we're actively working on expanding that set. If there's a change that gets made that can't be updated at runtime into the running application, there's a bunch of events that get fired to runtime. The runtime lets the system know, the tooling know, and then we fall back to just restarting the application like we always have, if you want. In Visual Studio, it'll actually give you that option. Say like, hey, you've made a change to this app that can't be hot reloaded. Do you want me to restart the app for you in order to have that change applied? And you can decide, oh, do I want to do that now or do I want to hold off for a little bit? So for project references, I'm guessing that, and new files, I'm guessing both of those right now are considered rude edits. That means that they're not supported for hot reload just yet. But you go check me on that, like give it a try and see what happens. But if you're using .NET Watch, by default, .NET Watch will fall back to just restarting the app if you make a root edit so that you can stay in that iterative dev flow. All right.
Excellent.
Hopefully that answered that question. All right, let's look at error boundaries. So moving on. And I'll have time at the end also. If I miss your questions, we'll do a sort of a open Q&A at the end. You can save it for then too. Okay, so I'm going to introduce a deliberate bug into my humanize last modified method here. I'm gonna paste in a little code. So this is saying that if the image ID happens to be 1, then invalid operation exception, okay? And the image that's ID 1, I think is this last one. You can see at the URL at the bottom, localhost edit /1. So that happy kitten is gonna be the problematic kitten going forward. So I'm gonna go ahead and click save to make that change into the app. And yeah, you can see already at the bottom, that again so we can get it. There we go. And we got our dreaded, yellow bar of death that says that there's been an unhandled exception that happened in Blazor. And if we go into the dev tools, we should be able to see that exception. Let me pin this to the bottom so it's a little easier to see in the console. We flow the exception, so at least during development, so you can see what happened. So we had our unhandled exception. How can we do a better job of handling this exception? Well, we can do that using the new error boundary component. So the error boundary will set up some unhandled exception handling for us in the component tree. And for this app, I'm going to put it initially in the main layout. So in the main layout, this is where we're rendering the body of each of the pages in this sort of layout structure. And I'm just going to wrap this body in the new error boundary component. So what will that component do? Well, if everything's going smoothly, no exceptions, then the error boundary component will render its child content, which will be the body. If there's an unhandled exception that happens, then instead of rendering the body, the error boundary component will render some error UI. And here it will use some sort of default UI. So I'm going to go ahead and save this. I believe this is a case where this is actually considered a root edit. So we'll see like the app, this takes a little bit longer to pick up. There's the little doop, 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 the .NET watch as it restarts the app. So weren't able to hot reload that one, but we're trying to expand the set of .NET hot reload scenarios. And yeah, now we don't get any page content because there was an unhandled exception by our component down the component tree. And instead we're getting this little default UI. Now, what is that default UI? Let's go back into the DevTools, and we'll select that element. And you can see it's just a div by default. It's a class, a div with class Blazor error boundary. Zoom in a little bit so you can see that. Okay, so just an empty div. Well, then where's all this, fancy colors and icon coming from? Well, that's just some styling that we're doing in the app CSS file. We include this in the default Blazor template if you want to use it. Down here at the bottom, we're setting, a background image and an icon, and even adding the text. The text is not even included by default. So that's where that's all coming from. It's in the app that's styling that particular div. But you can completely customize what UI the error boundary shows in the event of an error. Let me show you how to do that. So I'm going to change this error boundary and swap it out for a different one. So this error boundary is explicitly setting the child content to be the body, but then it's specifying the error content. And we get a context variable, which has the that's the current exception that was thrown, and then I can put whatever razor markup in here I want. Here I'm using this error details component, which I've defined in my app, and that's this guy, and it's just doing a div with some details and printing out some of the exception details. Okay, so if we save that, and just give the app a second to restart and apply that change. Yeah, okay, so this is my custom UI now. So we've set up an error boundary, and then we have custom UI, and we can actually see all the details of the exception. Now, putting a general error boundary like this in the layout, and also printing out exception details to users, that's probably not something you should do. This is probably a little bit too broad for a valuable error boundary. So instead, we can actually scope this error boundary to where this type of exception happens. So let me undo this, come back to what we had before, and instead of putting an error boundary here, I'm going to put it in our index component around the image list item. Let's see what that does. So let me grab a little snippet, and we'll put error boundary right here. Format that. Okay, so now we've got an error boundary just around the image list item. So if everything's good, we should see the image list item. If not, we should see our default error boundary UI. So let's save that. Let that apply. Cool, and now if we scroll down at the bottom, you can see all the other image list items render just fine, but the one that's problematic, that's the one that's getting our error boundary UI. And of course, we can customize this again to make it look nice and be specific to this particular error case. So we're not just like, dealing with random errors and leaving our app in a potentially broken state. This is a known case. So now we're going to print a div with a nice little message and let that reboot. And yeah, okay, sorry, couldn't load this particular image, sad kitty. All right, so that's error boundaries. As you can see, error boundaries, they give you a really convenient way to manage unhandled exceptions in your Blazor apps. Any questions about that, Ed?
I've tried to use one within a component. Do these need to be at the parent level, or can you put them in individual components? And then if it is an error that happens in the uninitialized async, the problem I had is that error happened before the error boundary picked it up. So I ended up throwing the yellow bar instead.
Yeah, so you should be able to use an error boundary wherever. Shouldn't have to need to be a root component or any particular type component. Like in this case, I used it in a layout component and I used it in a page component. But you should be able to use it further down the hierarchy. You may not have seen the UI if the CSS styles maybe weren't picking up correctly, but they should. Like, I think the CSS styles are fairly, you're just pivoting off the class, right? Like this is the one we give, but yeah, it's just the error boundary, Blazor error boundary class. So that should pick up. So it should work regardless of where you do it inside the component hierarchy. As for all the cases that the error boundary catches, I have to go check the docs. Uninitialized may be one of those cases where it's an unhandled exception that can't actually be handled using this model, but most cases should be handleable. I don't remember if we already have all those cases docked. I'll have to go look. Let me go check on that, and we can post a link maybe later to the error handler.
Eagle has an interesting question. Are there any considerations for catching specific exceptions?
No, I don't think the error boundary has an exception type on it. At least not that I'm aware of. I think it's just general. Let me see here. Not that I'm aware of. I think it'll just do any unhandled exception, and then you have to pivot off of the exception type. Like you get the exception here in the content, and you can do something. I think there is a way to continue, but with it's not like try catch with a particular type, so it's a little different than that. So not that I'm aware of.
With me tinkering around too, I believe I saw an API in there, so you can provide like a retry button.
Yeah.
So
yep.
You can retry the logic that it failed on, and it will.
You can basically reset the error boundary so that it's once an error boundary gets into it's handled in exception state, it'll always render the error content. The reset logic is basically a way of telling the error boundary, go back. Things are fine now. Let the good content render again.
Very nice.
All right, let's move on. So next, I want to look at state persistence. State persistence specifically during pre-rendering. Now to do this, I'm actually going to get rid of my little error that I introduced previously. That, save, make sure we're still all good. All right, so for state persistence during pre-rendering, do I need to refresh this? Yeah, okay. So pretty much all of the markup in this application is being produced client side. And we can see that if we look at its source. Let me do a Control U, and this is the actual source that got downloaded for this app. And you can see it looks pretty Spartan. Like there's not much that's being generated from the server. Instead, all of the UI markup is actually being generated by Blazor in the browser, like client side. Now, often we want to actually render the initial markup for the app from the server. And that's better for a variety of things, like search engine optimization, so that the content of the site can be statically analyzed. And it makes the perceived load time of the app feel much faster. You basically get pixels on the screen right away, while Blazor is being downloaded in the background and set up for interactivity. Now, Blazor supports server-side pre-rendering. It's one of the nice things about having .NET on both sides of the wire. And we can enable it in our server project by simply changing the render mode in our host page. Excuse me. So let's go into our server project. And let's find our host page. So _ host.cshtml. So this is a Razor page. This is code that's actually going to runs on the server to generate the initial HTML for the app. Just like in an MVC app or a Razor Pages app. Here we have the component tag helper that's being used to put a marker for where do we want our Blazor content to live inside of this page. And so we're pointing to the root component for our Blazor app. And then currently the render mode is set to default, which is WebAssembly. But we can change that to say we would like this to be WebAssembly pre-rendered, okay? And so that's going to now tell this page to first run our components server side, so that we can generate some initial HTML, and then in the background, the components and the runtime will get downloaded client side so that it can be set up for interactivity. Okay, so I think that's all we need to do. Yeah, so now we should be able to, to see this in action, let's refresh the app, I think, and make sure this is working. All right, and if we look at the source, I need to actually do a restart. Hold on, let me get this up. Get that change applied. All right, now
really helpful stuff for SEO. Because
yeah, so
just those two screens you just showed, the empty one is generally what the search engine sees, and with pre-rendering on, this is what the search engine sees.
So it sees all the initial markup. So we get all the initial markup in the application. So that's nice. Let me put this back to the side. Windows is didn't put that exactly where I wanted it. Okay, great. So now we have all the initial markup. So the initial page loads should be quick. Unfortunately, there is still a problem. And you may have seen this if you tried to use pre-rendering. Let's just highlight the problem. Let me put this in a new tab, and let's watch what happens as the app loads. So initially, we see the content for the app, and then it disappears. And we see the loading spinner while the client is fetching the image data from the server. And then we see the content again. Now we're kind of exaggerating that in this app because we've got this little 2-second delay in onInitialized in the index component. But still, this problem would happen even if we remove that delay. It would be like a flash. You'd see the content and it disappears, and then we see the content again. Well, that's annoying. Why is that? Well, what's happening here is after the initial page loads with all the HTML that got downloaded from the server, Blazor starts up on the client. It has to fetch the image data again from the server. And that's because nothing transfers the image data to the client from the server. We're only getting that pre-rendered HTML. The component then renders the loading spinner while it's fetching the image data on the client, which removes all of the pre-rendered HTML. So basically, we're rendering this, and that's stomping over all of our nice pre-rendered content. So that is pretty annoying problem, but fortunately, there's now an easy way to fix this in .NET 6. So in .NET 6, what we can do is we can persist data from the server that was used during pre-rendering so that it can be reused on the client. And the way we do that is using a new service called the component application state. So let me go ahead and add that to my index page. All right, so component application state's the new service. I'm also going to implement iDisposable. I'll show you why in just a second. Now, if we go down to our onInitialized async method for this component, right now all it's doing is that HTTP request to get the image data from the server. But we're going to change that to persist the image data using the new service. So let me do this. All right, what does our new logic do? OnInitialized async will now hook this event on persisting on the component app state service and wire up an event handler. The component app state service will then let this component know, hey, now is the time to persist your data. We're in the middle of pre-rendering. Go ahead and persist your data. And in our persist image data handler, we're using the component app state to persist the image data and then returning. Then back in OnInitialized async, we check to see if the image data has already been persisted, if it's something that we can just reuse. If it can't, then we go ahead and fetch it from the server. If it's already there, then we just use it because we don't need to fetch it twice, okay? And then lastly, we implement iDisposable so that we remove our event handler so we're not accidentally leaking event handlers. Now you may wonder, like, well, where does the data actually get persisted? Well, that happens on the page, like it gets persisted into the page. You may have seen in our host page below the component tag helper, we have this other tag helper now, persist component state. And that's how you can say, where on the page would you like any component state to be persisted? Okay, so let's go ahead and save all that, get that running, and let that reload. Okay, so now if we do that same test again, we're gonna grab the URL and go to a new tab. And let's go ahead and load this. The page loaded. No loading spinner, so that looks good. Let's make sure that we have all of our pre-rendered content. We still do. And then now down here at the bottom, you can see there's this Blazor component state comment with a blob of data with all the whatever state we asked to be persisted into the page. That can now be reused on the client, and the page loads fast. We can hit refresh all we want, and it looks great. All right. So
I've got a question for you, Dan. How would you compare this to view state in an ASP web forms application?
I knew that question was going to come up. Everyone, all the web forms developers are shouting, "That's view state. That's view state." I mean, it has some similarities to view state. I mean, the differences here is that you're really controlling exactly what you want to persist into the page. Like we're not as a framework defining a bunch of UI state for you and persisting it into the view. This is state that's just being defined by your app that your components need in order to reinitialize themselves. So it's a much more fine-grained, lower-level concept than view state in web forms. I know, like with web forms, if you were a little naive, you could end up with view state that was huge and not even know what was going on. With this model, it's very explicit. You persist what you want. If you don't want it there, then don't persist it. Only persist exactly the data you need to initialize your components.
And in this scenario too, it's only on the initial page load from the server. It's not like early web forms days where it's passing this back and forth consistently on every request.
Yeah. If we were to navigate away from this page and then go back, you would actually see the loading spinner By navigate, I mean like within the Blazor app. If you navigate and come back, you would see the loading spinner at that point because it has to go refresh the image data from the server instead of potentially using stale data. So yeah, it is just about that initial pre-rendered page state. Good point.
And then somebody asked in chat here, Elliot Brand asked, whoops, it's moving the chat while I'm trying to click and highlight. If somebody navigates away before it finishes loading, what happens?
If it navigates away before it finishes loading, like the background, like I assume they mean like the runtime itself. So you do need the runtime for full interactivity. So if you're talking about like, in-app client-side navigations, which are normally handled by the Blazor WebAssembly runtime, that interactivity isn't actually there yet until the runtime comes down. So there's a little delay between when you get the pre-rendered content and when interactivity actually is available. It's very short, but it's basically dependent on how long the download takes into your application. Once the runtime is there, though, if you try to navigate, then everything just functions as normally. All right, yeah, so that's persisting pre-rendered content. It's a cool feature. Try that with .NET 6.
It's a great improvement over what we have with .NET 5, by the way. That's an amazing feature to have, because you had that double hit, and there's many a blog posts on ways to work around that in .NET 5, but now we have something out of the box. It's fantastic.
Built in. Okay, next I want to show one of the features I'm really excited about, which is Blazor WebAssembly ahead of time compilation. All right, now to do this, I'm actually going to shut down the app running in .NET Watch. I'm going to get it running in IS Express, just so that I have it running on a different port. There we go. Okay, so now this app is a picture editing application, right? And so we can click on one of these images and do some basic editing on these images. You can actually like remove parts of the image. For example, if we wanted to make this tennis player's life a little bit more interesting, we could just remove the ball. So let's just select the ball and poof, it's gone. So this is doing some very basic image processing. It's got a little pattern match algorithm that's implemented all in C#. Here's the actual code for it. This is derived from an open source implementation from this person right here. So thank you for your contribution to .NET open source. Yeah, and so we can try and remove some more stuff from our image. Like let's say we want to remove this URL up here. We can try and
if you could only do this with my student loan debt.
That's right. Yeah, I did decent job. It's not perfect, but okay job. Let's try to do something bigger. Let's try and remove this whole logo right here. So I'm gonna very carefully. My wrist is like straining to get this, and there. All right, let's see if we can remove that whole logo. Going, gone. Yeah. Okay. Cool. I mean, it's not, like I said, it's not a perfect algorithm, but it did it. A little sad though is that it took a little while. It wasn't particularly fast. Why is that? Well, that's because Blazor WebAssembly by default runs on a .NET IL interpreter. There's no JIT in Blazor WebAssembly. It's just not something that the WebAssembly spec allows for. So that runtime is perfectly fine for most UI scenarios, but it's not particularly great for like CPU intensive tasks like image editing, like this. But to speed it up, we can try out the new support for Blazor WebAssembly ahead of time compilation, or AOT compilation, in .NET 6. WebAssembly ahead of time compilation will take our .NET code and pre-compile it to WebAssembly so that it runs much faster. Okay, now to try out the new support for WebAssembly AOT, you need to first install an optional .NET SDK workload, and you do this from an elevated command prompt. Okay, so what you do, go ahead and get CMD or your terminal of choice, and you want to run as admin. And once you've got that up, make this a little bigger. This is the command you run: .NET workload install Microsoft Net SDK, Blazor WebAssembly AOT. And this is in the blog and in the docs, so you don't need to remember this. But I've already run this on my machine, and that will pull down the tool chain that's needed for WebAssembly ahead of time compilation. All right, once you've got that, you go into your Blazor. Oh my, that's a preview version of ES. Let me close this solution and see if I can get. Oh, looks like VS is. Okay, yeah, let's reopen the solution so we can get this running again. There will be bugs when you're using preview bits.
I'm sharing the preview blog post in the chat for folks as well if they want to go look at the latest release and see the things that you're talking about here today, Daniel.
All right, what is going on? Why can't I open the project? So I want to see the project file. Let me try closing this all the way down and open this again. Sorry, folks.
I blame JavaScript. I don't know.
Yeah. Well, we're using a preview version of VS with preview builds of the .NET SDK, so sometimes things get a little cranky. Let's try this one more time. All right, we're running fine. Get this side by side. And let's try this. Okay, great. All right, so then once you've installed the .NET SDK optional workload, you also want to run AOT compilation true and add this property to your CS Prosh file. Okay, so when you've done that, you now have AOT enabled for this project. Cool. Where was I? Okay, now a couple of notes when you actually go to try this. The first thing is that running WebAssembly AOT compilation takes a little while. Like it's not a it's not a fast step. Running AOT on this app actually took me about 10 minutes. So we currently only perform AOT compilation on publish. We treat it as like a publish optimization step. Speeding up AOT compilation is something that we're looking at and working on. Also, when you do AOT compilation, it will make the runtime execution faster, but it will also increase the download size of the app a bit. An AOT version of a Blazor WebAssembly app is generally about twice as big. I know some people had thought that AOT would actually make things smaller, but it doesn't actually make things smaller. The .NET IL representation of code is actually very compact. When we turn that into native code, it's like running Engine or CrossGen or ready to run. The native representation actually tends to get a little bit bigger. So this is really a trade-off between some load time performance for your app and runtime performance. And whether that makes sense will depend on your particular application's scenario. For many apps, you don't need AOT and the IO interpreter is just fine. If you're doing some CPU intensive stuff, AOT all the way, okay? Now I have an AOT version of this app already. So let's go ahead and run that. I'm just gonna CD into the directory. I did a release publish and what is it, net 6 and then publish folder and
I could see this being useful for us at Telerik maybe to do some of our document processing with AOT compiled version of that tool.
Quite possibly.
That's very, very processor intensive to do in WebAssembly.
All right, I'm going to get the published version of our picture fixture app running. I'm going to bring that up in the browser. Okay, we've got the same application. Let's go back to our tennis player. Let's make sure things are still working after some unhandled exceptions. Okay, yeah, that's working great. All right, let's do the logo again. This big logo. There we go. Oh yeah, so 0.3 seconds. I think before, what was it like? Let's get it.
Can we do the cat?
hold on. Let's make sure this is the non-AOT version. I think this usually takes like 6 to 8 seconds. Yeah, 6 seconds. So like 20 times faster or so to run it with AOT. So much faster runtime performance. And yeah, we can now do all sorts of fun image editing like this. This gray kitten, I don't know, this face, some people say this cat is cute, but I think this face just creeps me out. Like, I feel like it's staring into my soul. So why don't we just fix that and just erase that right there, and perfect, much better. You can hear all the cat lovers in the audience just groaning in pain.
Perfect, no pun intended, right?
No cats were actually hurt in this demo. But Blazor WebAssembly ahead of time compilation, it makes your apps run much faster for CPU intensive tasks. Although it does increase the download size. Now,
we've got some questions here, and I think it might actually be pretty easy to answer. So Eagle and Elliot were asking about other versions of Blazor, other runtimes. Is this going to be handy for things like Blazor Server and MAUI? But correct me if I'm wrong, Daniel, those don't use WebAssembly. Those use the standard .NET runtime, so you don't need AOT.
That's right. Yeah, Blazor server apps, all your .NET code is running on the server. So you're on full .NET 5, You've got a JIT-based runtime, so it's converting IL code to native code on the fly for you at runtime. Very fast. Arguably the fastest way you can run code, almost the fastest way you can run code on the planet. So it doesn't get any faster on the server. You don't use AOT there at all. There are potential scenarios for using the AOT pattern with server apps in the future. Like maybe you want to create a single, heavily linked binary for your server code that you're going to deploy into a Docker image. Those things are things we're also looking at, but that's not WebAssembly ahead of time compilation. That would be like native AOT on the server. When we go look at Blazor in hybrid applications like in .NET MAUI, again, you're not using WebAssembly there. You're running on normal either .NET 5, .NET 6 runtime, or maybe the mono runtime if you're running on a mobile device. Your .NET code is running directly on the device. It's not running in the browser on WebAssembly. So WebAssembly AOT isn't needed.
Excellent. And then Mr. Magoo asked these way early on, and we held him for the AOT segment here. He wanted to know, does AOT, how does that affect lazy loading? Does it change anything with the lazy loading DLLs? And I would assume maybe how are those assemblies lazy loaded once they're AOT compiled?
Yeah, that's a great question. So with lazy loading, what we're doing is we're basically like delay loading .NET assemblies and giving you an opportunity to load them in the app whenever you want, like whenever is appropriate. Usually it's done based off of the route. Like if you browse to a particular page, okay, now please load this assembly because I only need this dependency here. When you do WebAssembly AOT, you're basically taking all your .NET IL code and turning it into a single WebAssembly bundle. So you do lose that ability to like slice and dice a piece of that app off. Now you may ask, well, can I slice the WebAssembly bundle into different pieces and dynamically load the WebAssembly bundles? That is something that we're looking at, but there are limitations right now with dynamic loading of WebAssembly bundles. Like there are size limitations on them. They have to be actually pretty small. So it's not something you can really do today. So you do lose out on lazy loading if you move to the full AOT model. It is another trade-off that you make.
And those are shipping as WASM files. They're no longer DLLs.
Right. You get all of the AOT code in a single WASM bundle. It's actually will all get linked in together with .NET.WASM. So you'll notice your .NET.WASM file gets a little bigger. Oops, I apparently got some things that are still running. When you look at the download trace for an AOT app, it is kind of interesting because in addition to that .NET WASM bundle, you still will see DLLs being downloaded with your app. And we often get questions about that. Like, why am I still seeing DLLs if I've AOT'd the app? And the reason is that there are scenarios where AOT.NET code can't handle specific .NET runtime features. Like if you need to do code gen, or if you're like, having use of reflection. In those cases, we actually still fall back to the IL interpreter so that your app still functions as normally. And for those scenarios, we actually need the metadata from the .NET assemblies to make them work. So you still get the .NET DLLs as well. So don't be surprised if you see that. There may be some additional trimming that we can do on those DLLs to make them as small as we can. That's all part of a broad effort that we have in .NET 6 to actually decrease download size all up for Blazor WebAssembly apps. And we've actually made some really good progress there, which was what I was going to show next. Do you want to see a really small minimum Blazor? Well, small is kind of relative here, but at least much smaller
Blazor. I saw Minecraft come up for a second. I thought you were going to tell us you built
Minecraft in Blazor. No, unfortunately, no. This is a very minimalistic Blazor application. It's got the counter, so we can click a button, and it's doing some basic UI rendering. I actually deployed this Blazor WebAssembly app with the help of a friend as an Azure static web app, which is a really kind of cool service. I'm going to make this bigger for deploying static like Jamstack style applications or Blazor WebAssembly apps with like a serverless backend. So that's how this app is deployed. But this app, we linked down as much as we could and made it as small as we possibly could. So we removed Bootstrap, we removed any unnecessary components, and let's see how big this one is. So a default Blazor WebAssembly app with .NET 5, like if you just do File New Project and published it, it weighs in at about 2.2 megabytes, I think, is the size. If I clear the site data for this app. And
judging by the URL, your friend was Anthony Chu.
It was Anthony, yeah.
Who has an excellent blog, and if you find him on Twitter, make sure you follow him. for some really good blog posts on Azure stuff.
Anthony does some really great stuff. And thank you, Anthony, for your help here. But this app is 1.1 megabytes transferred. So yeah, this is about it's half the size of a default Blazor WebAssembly app in .NET 5. And it's about 35% smaller than the equivalent app. Like if I built literally this app in .NET 5, this app is about 35% smaller. So we are doing work to shrink the size of Blazor WebAssembly apps. We do have some good size reduction gains in .NET 6. How did we do this? We did this a couple different ways. One is better .NET IL linking. The .NET IL linker is much smarter in .NET 6 about going through your DLLs and trimming out any unused code through static analysis. We also are using the same toolchain that we use for AOT compilation to do runtime relinking. So the .NET WASM bundle is normally just a static bundle that it comes down with your app. You can't really change its size. But with the new toolchain, we can actually look at which runtime features your app needs and link out runtime features that you may not be using. For example, this app is set up to use invariant mode for globalization, which means the toolchain can go into the WASM bundle and remove all the stuff related to globalization that this app is not using. So that's a big size win, as well as just better data sharding of the globalization data. Like .NET has all these features so that you get really great localization and globalization. We're getting much more efficient with how we surface those features in Blazor WebAssembly. So much smaller apps in .NET 6. That's something you can also look forward to. So even though if you AOT it gets bigger, the thing that you're starting from is going to be smaller. Cool.
Very nice.
All right.
I've noticed, this may be a little bit anecdotal, but I've noticed too that your custom application code really doesn't make that file size increase a whole lot. There's a lot in that .NET framework, but as you're writing, a couple pages and components and views and things, that size doesn't just like drastically go up. It makes This
is the actual app assemblies. Like most of the app is core framework libraries on the runtime. When you start writing your code, most of the time the code you write is tiny. Like .NET IL is actually a very compact format, so you can write a lot of code and not have a significant impact on the app. You can run into trouble if you start pulling in like really large dependencies. Like if you go grab some megabyte DLL that has a ton of stuff in it and link and reference that from your Blazor WebAssembly app, that will increase your app size pretty quick. So be intelligent about what dependencies you pull into a Blazor WebAssembly app. Remember, it's going to have to be downloaded and loaded in the browser.
A question I get a lot, Daniel, is how does the size compare to something like Angular or React? And my answer is usually, well, you start off a little bit larger, but it's not this linear progression into a large file size, where the other side of the coin with Angular and React is you might start a little bit smaller, but those are pretty linear. The more code you write, that size kind of gets pretty big pretty fast. So the end game is generally about the same, but over the course of the size of your app, you might see some variance in those two things.
That's right. Yeah, and I mean, to be fair, Blazor WebAssembly's goal is not to be the smallest. We do have an inherent overhead of having to bring a runtime with the application, but our goal is to make sure that size is not an issue. Like it should be good enough for pretty much any application that you want to write. All right, so that is the web set of demos I wanted to show. So everything we've seen so far is improvements to using Blazor to write web applications. Now, so hopefully you've seen that if you're building a web app, we've got you covered. We've got lots of great stuff for building server rendered and client side rendered web applications with .NET 6 and ASP.NET Core and Blazor. But what if building a web app is insufficient for your scenario? What if you need more than what the web platform offers you, and you require full, unfiltered access to the client device's native capabilities? In short, what if you need an actual native app? Well, .NET has many great options for building native client apps. Arguably, we have too many options, but we have a bunch of ways to do it. If you're a web developer and you want to build a native app, one really compelling option is to build a hybrid app. Now, what is a hybrid app? Well, hybrid apps are native apps that leverage web technologies for their functionality. For example, a hybrid app might use an embedded web view control to render web UI inside of a native app. This means you can write your app UI using existing web technologies like HTML and CSS, while also leveraging native device capabilities. Examples of hybrid app frameworks include Electron, which is what was used to build Visual Studio Code, and Microsoft Teams. Also, another framework is Cordova, which is used by many mobile applications. So for web developers, building a hybrid app can have a lot of benefits. You can reuse your existing web development skills, your existing code, even your entire web app to build a native application. You get full access to the native device capabilities, including using native UI elements together with your web UI elements. Now, not every app needs to be a hybrid app, but for many scenarios, the hybrid app model can give you a really significant app development cost savings. So you can build hybrid apps, desktop and mobile apps with .NET and Blazor. Blazor hybrid apps combine all the benefits of the web, native apps, and the .NET platform. In a Blazor hybrid app, like we were talking a little bit before, your Blazor components run natively on the device. They don't run in the browser, and WebAssembly is not involved at all. Your components run locally, and they render to an embedded web view control using a local interop channel. This means your Blazor components run very performantly, and they have full access to the native capabilities of the device through the .NET platform, through normal .NET APIs. You can use your .NET web skills and build native apps with web UI that can then be shared with your web apps. You get code sharing there as well. Now, work is already in progress in .NET 6 on the much anticipated .NET multi-platform app UI, or .NET MAUI. .NET MAUI is the future of cross-platform UI for .NET. With .NET MAUI, you can build a single app that runs on mobile and desktop, Android, iOS, Windows, and Mac. It's the evolution of Xamarin Forms, but with an improved architecture and development experience. .NET 6 also includes support for building cross-platform hybrid apps with .NET MAUI and Blazor. .NET MAUI includes a Blazor web view control that you can use to host Blazor components in your .NET MAUI apps. Since every .NET MAUI Blazor app is a .NET MAUI app, they can run anywhere .NET MAUI does. Although for .NET 6, our primary focus is on hybrid desktop scenarios. All right, so I'm going to show you now what it looks like to build a .NET MAUI Blazor app. All right, so let's go back.
That's super exciting for me. I think this is really cool technology.
Can close the browser and let's create a new project here. Now, I got MAUI set up on my machine. To install, to set up MAUI, you need the .NET 6 previews. You need to install the MAUI optional .NET SDK workload. And there's a tool called MAUI Check that you can just run that will put everything on your machine that you need to run MAUI. So go check out the MAUI docs to get all the getting started steps. Once you've done,
run MAUI Check more than once. Run it twice.
Yeah, it should be good enough to run it once. Hopefully, if you're having to run it twice, let us know, because that shouldn't be needed. It's still in preview, so there's lots of wrinkles still to iron out. But yeah, should only have to run it once. But once you've done it, you should now have the MAUI templates. Here's the normal .NET MAUI app template, and then we also have a .NET MAUI Blazor app. All right, so let's click next and create one of these. That seems like a great name for our .NET MAUI app. And we'll go ahead and create that. Now, this project is just, this solution is a normal .NET MAUI project. It has the same structure as a .NET MAUI project. We've got our core project right here. This is the project that we use for Android, iOS, and Mac Catalyst. Windows, of course, is a little special right now. It has these other two projects for running on WinUI. We're using WinUI under the covers. We are working on consolidating these projects into the core project, but right now they need to be separate. Okay, so let's go ahead and run. Let's start on Android first, and then we'll take a look at the code. While this is building and deploying, let's go take a look and see what we've got here. So in mainpage.xaml, we can see that we just have basically one MAUI control in this app, and that's this Blazor web view control. And it's rendering some static HTML. It's just a static HTML file that's in the project. Here it is. We've got a little tag to mark where we want our Blazor content to be rendered. And then we're pulling in the Blazor web view script, okay? And in that Blazor web view control, we're also specifying which component do we want to render inside of that control? Looks like the app is getting there almost. We'll give it another second. And here we're specifying the component type to be this main component. Now, where's that coming from? Well, from a Razor file, of course. Here in main.razor, this is our component, and you'll notice this looks exactly like the app.razor component that you would find in a Blazor app. This is just setting up the Blazor client-side router, which will then route to all of our pages. There's our counter component and our fetch data component, all the standard stuff that you would see in a default Blazor application. And hopefully it's now running, and it is. And yeah, there's our Blazor app running as a native Android application. We have an embedded web view control. Our components are running natively on the device, but they're rendering to this web view control. And all the normal Blazor stuff works. We got our counter and our fetch data page, all being rendered in the browser, in the native Android app.
Quick statement or question here. Does MAUI mean I won't have to worry about responsive or adaptive UI? I think the answer is the opposite.
Yeah, no. You always should worry about responsive UI. The benefit of this hybrid approach is that for your responsive UI, you can use normal web techniques for doing that. So you're using CSS and HTML to render all of this UI. This is the normal. I mean, we have a CSS file. We have Bootstrap that we're pulling into this MAUI app in order to do the rendering of this mobile application. If you're doing native UI in MAUI, then the XAML pattern has its own set of gestures that you use for building responsive layouts and so forth.
Yeah, I think the answer here for me is if I'm using MAUI, then I know I'm very specifically targeting more than one device. So I better be using those adaptive and responsive behaviors.
Absolutely. So one of the benefits here is we can actually use a combination of web UI and also native UI. So right now all I have is this Blazor web view control, but we can add some native UI to our app. And I'll spare you me trying to type out some XAML. But here, I have a little snippet that I added. We're gonna add a stack layout with a native label control. And then we have our web view control underneath with an option to make sure that it still fills up the remaining space. So if we save that and run this again, the second run should be a little faster because the app's already deployed. We should be able to get not only some web UI using Blazor, but also native controls. Now, if you're familiar with the mobile Blazor bindings project, that's an experimental project that we've been playing around with for a while that really informs a lot of what we're doing with .NET MAUI. There was a way there to also do native UI using Razor. That's not coming to MAUI in .NET 6. That's something we'll maybe consider in a future release. So to add native UI in .NET 6, you just use normal XAML, and you can see it works. Like there's our it's so native label control above the rest of our web UI, which was all implemented using Blazor. Okay.
The fact that you can commingle these two things and share state, I think, is just phenomenal technology, but also a great migration strategy for people that have existing code and they want to start going to Blazor. They can share some of these things in the same space.
Yeah, absolutely. You could start with native and add Blazor there and use that to go to web, or the other direction, if you're a web developer and you're starting with a web app and you need some native functionality, you can pull your web code into a native application. I want to show desktop as well. So let's set the WinUI package project as the startup project. This trips up a lot of people right now. This is the project you run, not the WinUI one, the WinUI package one to run the desktop version. And so we'll go ahead and run that. And this should run our hybrid app as a desktop application. This is using WinUI, the latest Windows UI stack. And there we go. Yeah, and so we still get our native control. This is now a WinUI native control at the top, and we've got our Blazor UI. Nice. The default template is fortunately responsive, so it works on big screens and desktop apps and on mobile apps as well. Now, one thing that's really cool about running an app this way is, in addition to using native UI elements, we can also use any of the native functionality of the underlying device. Like, we're not running in the browser sandbox here. We're running in a native app, so we can do really cool things. Like, let's go into our index component. This is the home page for our app, and let's add some code in here. I'm just going to add a string variable. We'll call it message, and we'll say hello. And then I want to render that message up above. We'll put it in an H3 tag. Right, and then what I want to do is have a button here where I can edit this message. So I'm going to add a button on click, and I'm going to put an event handler here that I haven't defined yet. I'll define it in just a second, and we'll call this our edit button. Okay, and then now for my edit functionality, I'll just copy in some code I've already got, and we'll format that. Okay, so what do we got here? So we've got a button that on click is going to call get message, and in get message, what I want to do is launch an advanced text editor for editing the message that we're displaying in our native MAUI app. So what this does is it creates a temp file on disk. It writes some placeholder text into that text file, and then launches our advanced text editor. Waits for the user to specify what message they want and to close the process, and then reads the file in again and renders that message. Okay, now let's go ahead and run this app again and see if that's working.
So file interop, very cool.
Oh,
you could
speaking of files,
essentially pop notifications on the Windows tray and all sorts of cool stuff with this.
Yeah, speaking of files, I needed a using statement so I can actually interact with the file system. Not something you can do from a web app, right? You're not going to be able to mess around with the file system in a web application. But because we're running in a native application, we can now click edit and launch our advanced text editor. .NET MAUI Blazor is great. Maybe we'll take advantage of our advanced text editor features. Put some emoji in here and close that. And it's able to pick up the string that we just saved to disk. Now, obviously, that code was Windows specific. We would need to put an if-def around it to say, like, only run this code in the Windows version of this app. But the point is that you can touch anything in the .NET platform. You get full access to the native capabilities of the device. So yeah,
so cool.
Simple example. And you mentioned like system tray integration. Like one of the demos that we showed at Build was we built this weather application, and we built this application actually twice. We built it once just using .NET MAUI and XAML, and then we built it again using HTML and CSS with Blazor, and that's this project. So I'll show the app first running as a web application. Imagine you built this web app, like you have an existing web app, and then you decide that you want to add some native functionality to it. So here's my web app. It's got a nice design. Got some things you can click on to see the stats from different weather stations. We can see the current weather in Boston. We can add some new stats. We can change the location to, let's go see the weather in Korea. We can change some settings to say we want to use metric units. This is all a web application, HTML, CSS, C#. But what if I wanted to add some native capabilities to this app? Well, we can do that using .NET MAUI. So all of the logic for this weather app is in this Blazor weather project. So here's all the components, like there's the home components and so forth. And that's just referenced by our web application. So just to show that that's the actual dependency, no trickery going on here. And then I just added a MAUI set of projects to this solution that reference those same set of Blazor components, unchanged. So we're referencing that same Blazor weather project right there, okay? And we can just use it. So if we look at how we set that up in the code, go back to main page.xaml. Again, it's just a Blazor web view control pointing to the main component. And in main component, all I'm doing is rendering the app component from the Blazor web application. That's it. All right. And so we can set this as the startup project. And let's run on Android first.
And I believe Curious Drive shared a link to this very project in the chat room.
Yeah, it's available on GitHub. So if you want to play around with, there's two versions of it. There's the one on my account, which is the web version. So here we have, the nice responsive version of our weather app now showing up on a mobile device. And we can also do it on Windows as well. Get desktop, get that up and running. Now this desktop app was actually augmented with some native functionality. Like where is that? I think it's in main page.razor. Yeah. So it has some like system tray integration, and it can fire off native notifications. That's all possible because we're using that hybrid app model. All right. So here's our weather app. This is not a browser. This is a native WinUI shell got all the same functionality again. But now if we look down the bottom right-hand corner, there's a little .NET bot hanging out in the system tray that was added by this WinUI app. We can click on him and we can fire off native notifications.
Very nice.
This same app runs equally well on Mac and on iOS. If I had my Mac device up here, we could take a look at that as well. But at least for now, we can see we've got mobile, we've got native desktop, and missed it, and web, all the same code using Blazor, using .NET MAUI and Blazor. So that's the new hybrid app model with .NET MAUI and Blazor. Super cool. Check it out in .NET 6.
While you have those three up, I just want to reiterate too, the one that's running on the web browser tab is using WebAssembly. The other two are running on the .NET runtime without WebAssembly. So
that's right.
There's there's a possible speed difference between these. You may be more performant on the MAUI hosted ones. Is that true?
That's right. I'm not sure if the server one might actually be running on Blazor server, so the component rendering might be comparable. I have to go check.
Yeah, that could be true as well.
I think it is a Blazor server version here.
Not that WebAssembly is slow by any means, but going back to that AOT conversation, if you had something very processor intensive that you need to AOT, that wouldn't apply to the MAUI versions of the app.
Yep, good. Cool. I'll just mention real quick also that if you're if you're looking to get to MAUI, one modernization strategy you might try is actually if you're a WinForms dev or a WPF dev, like you have an older app and you want to start adding modern UI that can carry forward into MAUI, we have Blazor WebView controls for WPF and WinForms as well. So you can do this same hybrid pattern with existing Windows desktop applications. That's something that we also have added support for in .NET 6. All right, we'll go back to slides real quick. So when are all these goodies coming? Well, .NET 5 released back in November, and we're basically on a yearly release cadence with .NET. Every other release, every even-numbered release is a long-term support release. So .NET 6 will be an LTS release, and it will ship in November of this year. And then we'll have a yearly release cadence after that, where every odd-numbered release is a current release, and every even-numbered release is an LTS release. So .NET 6 is already in progress. We just shipped .NET 6 Preview 4, and we expect to have a preview about once a month from now until we ship in November. So be sure to give it all a try. Like I said, .NET 6 Preview 4 is available. You can try out hot reload, error boundaries, state persistence, WebAssembly AOT, .NET MAUI Blazor apps, the WinForms and WPF controls are all there as well. The improved performance, you can get it at .net/get-.NET 6. And with that, I think I'm done, and I'm happy to answer any other questions that people might have.
There was a question in chat, and I'm trying to remember. I think it was Timebender360 asked it. It wasn't fitting into the flow of the show yet, so I saved it for the end. He was asking something about Blazor server apps, and he was wondering if a Blazor server app in .NET 6, does the connection to Azure SQL always stay connected like Signal R? And is there any improvements coming in .NET 6? I'm not an Azure SQL person, so I don't have any idea what they're talking about.
Okay. Well, I mean,
off to you.
Yeah, sure. So, like, how does the Blazor server app work, right? Like the user connects in the browser to the server, and we set up a WebSocket connection then to the server. All the Blazor components run server side, and they handle rendering the UI and shipping that down to the client. And as the user interacts with the UI in the browser, we send those UI events to the server so that the components can then handle them. On the server, associated with that user is what we call a circuit, like some state for that particular. You can think of it as like a session. We don't really call it a session because it's slightly different, but that user's interaction with the website. Then what you do on the server to talk to your databases or any other APIs or whatever, that's completely up to you. You can, of course, set up a database connection directly to SQL Azure from your server process. You may be running that server process on Azure already. And then how you manage the lifetime of that connection is up to you. So you could scope, for example, the DB context, if you're using any Framework Core, to the lifetime of that particular circuit. And so the connection will basically live for the duration that the user's using that particular, duration that the user's using the app. If you wanted to have it be a singleton, you could do that. I think in general, the EF Core folks recommend scoped set lifetimes for their DB context, or at least making them as short as possible. You can actually even just new up a context, do whatever work you want with the database, and then tear it down. So that the lifetime of the database connection is really in your hands because your code is just running on the server.
And before we get to more questions, I just want to let people know we do have prize drawings going on, and we're going to announce those at the end of the show, so don't go anywhere. So just stick around for a few more minutes. We had another question come in. Can a Blazor MAUI app interact with background tasks of a device even if the app is closed? That's a great question.
I mean, it's a fully native .NET process. So you can, anything the device can do, you should be able to do. If you want to call into like native Windows, Win32 APIs, you can do that. Like you p-invoke to your heart's content. All those things are possible. So yeah, absolutely, you can interact with background tasks. No problem. MAUI tries very hard to give you common abstractions over common tasks that you might want to do across all the different platforms that it supports. Like if you want to do something on desktop, Windows app, and Mac, and iOS, and Android, well, the way you do those things on the different native platforms is probably different. So MAUI gives a bunch of convenient APIs for dealing with location, or there's a whole the system tray integration. I think was in part done with one of these MAUI abstractions, so that can help. But you're not constrained by those APIs. Like if you want to touch native functionality, you absolutely can. So the sky's the limit. Whatever the device can do, you can do from your MAUI app.
Excellent. I think that also answers the next question that was up there about device capabilities. As you said, there's kind of a broad range of common tasks that this takes care of. And then Elliot Brand had a question about troubleshooting an HTTP client MAUI app that was crashing the Android emulator. I rather than try to troubleshoot on air, where's the best place to report these type of issues, Daniel?
So the MAUI repo is on GitHub, github.com/.net/MAUI. For that particular issue, I would 99% guess that the issue is with HTTPS. I believe there's a known bug in MAUI right now where they're having the HTTP client stack blows up when you try to do requests to HTTPS sites from some of the platforms. It may be specific to Android or something. So try doing an HTTP call without HTTPS, which I know is terrible. We shouldn't be recommending to anyone to do HTTP instead of HTTPS, but just to work around the bug until they get it fixed. My gut is that's probably the problem you hit. I hit a very similar problem when I was building the Blazor weather app.
Okay, excellent. For Blazor, WASM, and MAUI, can source code be viewed by client devices? Are there any security issues a developer needs to be aware of on client-side rendering?
So not your source code. So it does surprise some users that are new to MAUI and are used to server-rendered web apps to see their DLLs getting downloaded to the browser. They're like, whoa, those are my DLLs. Does that mean they can decompile them and look at how they were originally built? Yeah, that any code that's going to the client, you should effectively think of as public. It's on the user's device. The user has the compiled version of the code. They're not going to get the source code unless you're shipping the source code with your app. Hopefully you're not doing that. But they do have the actual compiled assemblies. And that's true for MAUI as it is for Blazor WebAssembly. So keep that in mind. Don't ship any IP, in your assemblies down to the browser that you don't want users to be able to see. It's not a security issue. But big
surprise for some folks is that this applies to Xamarin as well.
Oh yeah,
by the way.
Yeah, Xamarin apps are you're installing a Android or iOS app that has a .NET runtime with your .NET compiled code inside of it, of course, and it's a client app running client side. It's very different than a server rendered app where your code is all staying on the server and the user agent's only seeing your rendered HTML and JSON. I also, regarding security as well, in Blazor WebAssembly, I want to make sure it's clear that we're not doing anything fancy to punch out of the browser security sandbox. We're running on WebAssembly, which is an open web standard. So all of the browser security sandbox constraints equally apply. You can't do anything in the Blazor WebAssembly app that you couldn't already do in JavaScript. And likewise, you can do anything that JavaScript could do. So that's the constraint that's put on you by the browser when you're running in a Blazor WebAssembly app. In MAUI, you have a native client app, so the only constraints that are being put on you are by the platform. So if you're running on a mobile device, there may be permissions or capabilities that you have to specifically request or whatever in order to get access to those things, but you can. If you're running on a desktop app, for the most part, you can do whatever you want. Like it's basically considered a trusted piece of code at that point on the user's machine, within the security model of the underlying OS.
Yeah. So one of the things that I like to tell people is if you have something that you're worried about with IP, put it in an Azure function or hide it behind an HTTP call. Don't have that part of your application code, and that applies to any platform. Just don't ship it to the client, and you never have to worry about it.
Yeah.
So
don't take your WinForms app and then try to ship it all the way down to the browser. Like, you do need to think a little bit about what logic should be in the browser and what should not be. It may require some refactoring. But the good news is you can use your .NET skills, .NET code, existing dependencies. Just you do need to think about that this is a new app model.
All right, so just working a little background stuff here as we get through the questions. We're choosing some winners as we speak here.
Ooh.
I didn't look at the prizes. I don't get the prizes, so I didn't look at the prizes.
Free
I'm
copy
sure we've
of
got some good
Blazor.
stuff. Free.
Oh wait, it's already free.
A little bit about support. Is there any Blazor server support going away anytime soon, or is it just as popular as WebAssembly? Are we keeping all the things, Daniel?
It's technically, actually, right now it's more popular. I mean, Blazor server shipped first. We did Blazor server originally in .NET Core 3.0, and then it shipped again with .NET Core 3.1. .NET Core 3.1 has an LTS support lifecycle, so 3 years of support on top of .NET Core 3.1. It shipped as part of .NET 5, and it's shipping again as part of .NET 6. So with .NET 6, it gets another additional 3 years of support once we ship .NET 6 in November. So no, it's not going away. That core model of being able to render web UI to a different process is very fundamental to a lot of things that we're doing in Blazor. If you think about how MAUI and Blazor are working together, it's basically like a Blazor server app just kind of scrunched locally onto your machine. Instead of having the interop connection be a WebSocket connection that stretches across the internet, it's just all happening right there in process. So no, Blazor server is not going away. It will continue to be supported, and for many scenarios, it's great. Like, it's very simple and easy to get started with. Really fantastic technology to use.
And I'll ask one final question here, Daniel. Do you see MAUI and like Flutter being, or is it Flutter, the Google tech that's trying to do like the same, like write once, run anywhere type of thing? Are those kind of competing in that same space?
They do very similar things. So like they are definitely different options for very similar scenarios. So I mean, Flutter is based on Dart, and it allows you to write, I think, mobile and desktop, and then I think recently they added desktop and web. MAUI is trying to do very similar things, but with .NET and with C#. And it gets, the nice thing with .NET, you also get paired with a really great server stack. So you have .NET across the board. We've really been trying very hard to make .NET a dev stack that you can use to write anything. Web UI, desktop, mobile, games, AI, regardless of what you want to do, you can do it with .NET. I would also say that MAUI is a little different than Flutter in terms of how it renders the UI. Like, MAUI is a abstraction over the native UI controls from the underlying platform. So when I rendered a label control in my .NET MAUI Blazor app, on Android, that was an Android label. On Windows, that was a WinUI label. On iOS, it would be an iOS label. Flutter, I think, does a lot of its own drawing. But that said, in MAUI, we're also looking at doing similar things where you can have a cross-platform graphics stack. There's a library called, I think it's Maui.graphics, that will allow you to do similar cross-platform drawing as well within MAUI. So, very, very similar scenario overlap. Different technologies underneath the covers, and different scope of things that they currently support.
Excellent stuff. Yeah. So I appreciate having you here on the show to kick off our Blazing into Summer week. It looks like we're going to end up having to make this a yearly thing, Daniel. This Blazing into Summer looks pretty popular with folks, and Blazor's here to stay. So why not keep it up, right?
Sounds great. Love to. Thank you for having me. And man, I'm looking forward to the rest of the sessions.
And we have a winner. Mark Stega, I think is how you pronounce the last name. I'll post it in chat. Mark, we'll be sending you an email letting you know that you won a prize, and we'll be sending that out shortly to let you know what the prize was and how you can redeem that. So thank you all for joining us today. Again, special thanks to Daniel Roth. I appreciate you staying and answering all the questions that people had. There was quite a bit of them. So
My pleasure.
Excellent. Good luck to you and your team on November, and I'm sure we'll see a .NET Conf or something.
.NET Conf, November 2021. Mark your calendars. Yes, it's going to be epic.
Yes, and again, like Daniel said, we got great guests coming all week. I'll share this up on the screen one more time, and we'll let you get back to your day, Daniel. But we've got some really amazing community folks joining us this week. Tomorrow, it's Layla's birthday. Who streams on their birthday?
Happy birthday.
Layla streams on her birthday. So Layla Porter tomorrow from Layla Codes It. She's going to be working with Signal R and doing some speech to text and doing some language translation. It should be super fun. Eagle's going to talk about unit testing on Wednesday. If you haven't seen BUnit before, if you're a big fan of unit testing, I highly suggest you join us. Curious Drive, fantastic guy, does wonderful videos on YouTube about ASP.NET, Blazor, and .NET. He's going to join us. And then I'm going over to your neck of the woods, Daniel, and I'm going to join Cecil Phillip on .NET Live.
I love that style. Artisan Blazor components. I can just see you with like your planes and saws, carefully sanding your Blazor components, polishing them.
Very, it's like the bread making of the pandemic.
Kneading the Blazor components.
And then Fierce Kitten's fantastic Twitch personality, just fantastic personality in general. She's coming on Friday to share what she's working on with her GIFbot application, which is an app that runs on Blazor and it's built on her show and used by her audience. So very interested in seeing what she's up to. So with that said, Daniel, any final words?
Give .NET 6 preview 4 a try. Let us know what you think of the features, and if you have any suggestions or ways that we can make the product better, let us know on GitHub.
Awesome, and we'll see you here all week, folks. Thanks for joining us, and take care. Have a good afternoon.